Hello and welcome. My name is Michael Fisher and I work on the solar team at NRG Systems. In this webinar, I'll share some of the latest updates to NRG's solar measurement solutions, including NRG's latest approach to solar measurements, an introduction to LOGR-S, our new solar-specific data logger, a brief overview on how our new web software platform, NRG Cloud, can help streamline solar resource assessment activities, as well as our addition of the EKO STR-21G 2-axis Sun Tracker to NRG's solar measurements offering. We'll also talk briefly about some of the development we're working on, which will result in more updates throughout the year. NRG's approach to solar measurements is to take a holistic view and to keep our customers' goals, not just our own, in mind. This means not only supplying industry-leading equipment, but also wrapping all of the relevant services and support around it to make sure our customers achieve the best results. For instance, during the early bidding, design, and configuration stages of a project with NRG, our team consults with our customers to ensure that their requested system configurations will achieve IEC 61724 Class A level performance, that measurement systems are distributed appropriately throughout the solar plant, and that all aspects of the system design are exceptionally well documented to enable efficient and accurate on-site installation. As you may know, NRG has been designing and manufacturing renewables resource measurement equipment for nearly 40 years now, and we've been working hard in recent years to improve that offering specifically in support of our solar customers. One of the characteristics we've noticed about the solar industry is its great diversity of equipment and technology, and that each solar plant is unique. With our lean manufacturing approach, we aim to take the variability and guesswork out of getting high-quality, accurate solar measurements. When it comes to our SRM systems, our standard systems are available in two types of configurations: a complete station mounted on a Met tower, or a basic station mounted on the PV array itself with a reduced set of measurements. The complete configuration includes a full meteorological measurement system mounted on a 2 to 3 meter tower. The station will have Class A horizontal irradiance measurements on it. The system is powered by grid power, converted to DC, and optionally backed up by PV and battery for continuous operation in the event of AC power loss. Also standard on the complete system is a suite of discrete meteorological sensors, each optimized for their respective measurement, and individually replaceable should the need arise. This generally includes wind speed, direction, precipitation, temperature, pressure, and relative humidity. On complete systems, we typically include our Symphony Pro data logger, which offers 26 channels and can accommodate a wide range of sensor configurations. That was an overview of the complete SRM system. When it comes to the basic or array-mounted SRM systems of the type shown here, these typically entail a reduced set of measurements featuring a combination of plane of array irradiance, PV module temperature, and soiling measurements. The irradiance measurements include upward-facing global plane of array measurements, and if the array is bifacial, as shown in this example, a number of rear-facing POA irradiance measurements are usually included as well. Customers who utilize this type of station typically deploy them in greater numbers compared to their complete Met station counterparts, and distribute them throughout the plant. The measurement needs of these basic stations are an ideal match for the capabilities of our newly launched solar data logger, LOGR-S. The LOGR-S data logger is an advanced data logging system that is purpose-built for post-construction solar resource monitoring on utility-scale PV plants. Unlike more complex, general-purpose data loggers, LOGR-S features just the right combination of functionality for professional solar resource monitoring in 2022. LOGR-S's modular architecture enables flexible unit configuration and measurement capability. Taking a closer look at the logger itself, we can see that the analog module features 7 ports capable of high accuracy, high resolution analog measurements utilizing a 24-bit analog to digital converter. Each of these ports can be configured for either one differential analog or up to 2 single-ended analog measurements. LOGR-S has a built-in PV measurement module to enable soiling loss measurements via daily soiling ratio calculated based on the outputs of connected clean and soiled PV modules. The processor, or serial module, allows for flexible serial data acquisition with configurable Modbus settings. The 2 Modbus data acquisition lines, A and B, fan out into 4 hardware ports, 3 for A and 1 for B, all of which support up to 24 channels from a number of connected serial sensors. This module also features the 16 to 28 volt input power terminal, as well as the Modbus RTU and Ethernet ports for delivery of collected data to the local SCADA network. All of the measurement modules that we just looked at combine to form a sensor to SCADA interface that accurately acquires, stores, and delivers data from connected sensors to the local SCADA network. A wide variety of sensors are compatible with LOGR-S, including analog thermopile pyranometers, various meteorological sensors, both thermistor and RTD type temperature sensors for measuring back of module panel temperature, as well as a wide variety of serial sensors such as pyranometers, optical soiling sensors, and more. NRG designed LOGR-S to be easy to use, including making it simple to configure via built-in software using a web browser. This means there is no complex programming and no need to pay a logger manufacturer thousands of dollars to program it for you. Here we can see the process to add a calculated albedo measurement to LOGR-S. You simply choose albedo from the drop-down and then select the relevant input channels for RHI and GHI. Click Save and then navigate back to the Home page or Sensor Outputs page to verify that the new albedo calculated channel is set up properly. Scrolling down, we can see the added channel and its output. As usual with NRG, LOGR-S is backed by our standard 2-year warranty and lifetime technical support. We'll be doing a more in-depth look at LOGR-S in a separate webinar in the near future, so stay tuned for that. Another recent NRG update that should help streamline data collection and monitoring during pre-construction solar resource assessment campaigns is an upgraded version of NRG Cloud. NRG Cloud provides a way for users to process, store, monitor, and easily access data from ongoing solar resource assessment campaigns. Okay. Let's log into NRG Cloud and see how it can help with managing solar resource assessment campaigns. When we first log in, we land on the Home or Fleet view here, where we can see all of the sites on a map view in a list on the left, or by expanding that list in a table view. You can click on any one of those sites to look at them more closely. And here we have a solar measurement site that's deployed on NRG's campus in Vermont. There's some basic information about the site, its location, and a number of plots that show us the health of the site and some of the measurement data. Let's take a look at the irradiance measurements a little bit more closely. One of the recent updates to NRG Cloud included resampling data in these plots to help them load more quickly, and as you drill in, they load in higher resolution so that you can see all of the detail. The irradiance data look okay for the last 7 days on this site, although it's not very sunny in Vermont this time of year. But I'm curious to look at the timeline view to make sure that all of the data have been captured in the system. In the top row here we can see files represented, and it's apparent at first glance on this screen that there are a couple of files missing between February 20th and 21st. You can actually see the file numbers here, and we are in fact missing a couple of files. Once you locate those files, it's easy to import them via the UI. Simply drag and drop the missing files and click Upload, and those files will be loaded into the database for that site and no longer be missing on the timeline view or in the plots. So that's just one quick example of how you can keep an eye on and maintain the data record for a site using NRG Cloud while conducting a solar resource assessment campaign. The last update to cover today is the addition of EKO's STR-21G Sun Tracker to NRG's product offering. This 2-axis tracking device autonomously follows the sun path throughout the day to provide highly accurate, direct normal, and diffuse horizontal irradiance measurements. The NRG team has also developed supporting accessories for the STR-21G, like a mounting platform that attaches to most piles used for PV racking and tracker supports, as well as updates to our power supply designs to ensure reliable operation of this device. Well, that was a quick look at some of the most recent developments in our solar solutions offering, including LOGR-S, NRG Cloud, and the STR-21G Sun Tracker. Looking ahead, we have more exciting developments underway. We'll continue releasing new features and functionality for NRG Cloud, such as support for more measurement devices, as well as the IEA Task 43 data model. For LOGR-S, we're planning to release more features later this year, including support for additional measurements, as well as remote cellular communications. Thank you for joining me today. I really appreciate your time and attention. Don't hesitate to contact our solar team at the email address shown here with questions about what we covered today, or to learn more about our solar solutions offering in general.